having me. I would like to provide a brief introduction on swarm robotics and its application, or to be more specified, to talk about a team of robots that cooperate together to complete mission. I guess I don't have the control yet.
I guess now you have the control.
Yes, I have. Yes, thank you. Okay, let's see what's the benefit of having a team of robots instead of just one well-equipped robot. We can say a team of robots could perform to enhance the performance, increase the adaptivity, scalability, and flexibility. Of course, it can provide more robust, fault-tolerant, and easy-to-maintenance behavior, and eventually provide us less expensive plans. Let me elaborate these issues by some examples. You know that sensors and actuators have a limit range for performing. If we have several sensors or actuators that cooperate to each other, so we can have we can enhance this performance and make wider range for performance. For example, you can see here that UAVs can transfer some specific load. But if we have a cooperative team of UAVs, they can load more heavy objects. Regarding robustness and flexibility, we can bring an example for example, forest fire monitoring. When we have a team of UAVs, or unmanned aerial vehicles, when I say UAVs, when we have a team of UAVs or aircraft which are trying to monitor the fire, if one of them has some problem, so the other aircraft can continue the mission and maybe compensate the missing performance of the failed aircraft. If I want to bring some example for less cost mission, maybe a good example could be discovery in space. When we want to provide higher angular resolution in astronomical image, we require to increase apertures to telescope or increase baseline of interferometers. So the mass of the support of the structure of the telescope should increase. And we face the problem because propellant for launch and navigation of such a long baseline space telescope exceeds the technical and, of course, the financial boundaries. So what should we do? The scientists suggest to provide small and less expensive autonomous satellites, as you can see here, and perform a specific formation flight so they can behave just like a rigid body. In this case, they can accomplish the mission with less cost, and the good thing is that if one of the satellites fail during the mission, they can replace it easier with less expense. And this is very interesting mission that is defined in NASA and ESA, and they're working on it still. For providing more reliable and precise performance, maybe we can name cooperation between aerial and ground vehicles, for example, for monitoring. In this case, for exploration and coverage, UAVs can capture wide range, move fast, and provide a rough map of this environment. For example, they can detect big obstacles. On the other hand, the UGVs, which I name is unmanned ground vehicles, UGVs, move slower, but, and you can see it here, move slower and detect small obstacles. Now, if we have both of UAVs and UGVs as a team, so we can have more precise and faster map. And another good thing for having team of robots could be optimum behavior. For example, when we have a team of UAVs, if they form some specific formation, we can save energy. That I will explain about it maybe later. I guess I lost the control for the slides. Would you please? Oh, it comes back. Let me talk about some missions that are defined for team of robots. Thank you. One of the most popular missions that are defined for team of robots is consensus, which is to have a group of agents to reach a common assessment or decision based on distributed information and a communication protocol. Before I go further, I would like to mention that most of this cooperating control, the interesting thing is that we try to provide autonomous agents or members of the teams. They cooperate together and make decisions based on their local information. And we usually try to have distributed control instead of having centralized control. For consensus, we can have agreement with or without leader. When we have a leader, it means that usually leader make decision and follower just follow. But when we have leaderless mission, all the agents contribute to provide the final decision. And of course, many of the cooperative problems can be considered as a special case of consensus. For example, for formation, if we don't specify the position of each agent in the formation and the agents just make decision based on their initial values of course, find their position in the formation, we can have a mixture of formation and consensus. Or another mission that is relevant to consensus is rendezvous. The rendezvous is an agreement based on position, time, or both. It means that the agents meet each other on some specific position that they agree, or at some specific time, or they meet at specific time in a specific position that the time and position are defined based on cooperation among the agents. Another mission that we can name is swarming. Swarming is, or flocking, is a mission that is defined based on inspiration from living organisms like bees, fishes, or birds. They usually swarm or flock to find food, mating, facing with dangers or enemies better. And first time Reynolds in 1987 introduced this mission for a team of robots. And based on Reynolds, the idea that three rules should be respected such that we can provide flocking. First rule is separation, which means agents should avoid collision with their neighbors. Second one is alignment. They attempt to match velocity with their nearby flock mates. And the last one is cohesion. They should try to stay close enough to their neighbors. There are lots of interesting swarming and flocking that are defined and performed, and you can find interesting movies in the internet. I have provided you a swarming mission of 3015 drone, which is recorded by Guinness on September 2000. I hope you. Swarming and formation, they made some specific forms. Okay, let's continue the missions that we can have. Another mission, as you saw in the movies as well, is the formation control. That it could be a specific type of, sorry, it's slow, a specific type of swarming. It's in this mission that we have swarming, but we keep some specific geometric pattern. It's again inspired by geese formation for migration, and scientists found out that when the geese are farther from the top or tip of the V shape, face less drag, so they can fly longer. So we can take advantage of this idea and fly the aircraft in V shape. In this case, the aircrafts that are farther from the tip of the V shape can face less drag and consume less fuel. That is very interesting. Formation could be leader-follower based or leaderless. For leader-follower, a leader is responsible for tracking the trajectory, and the followers should keep the formation and, of course, follow the leader. But for leaderless cases, all agents are responsible for both tracking and keeping the formation. For leader-based approach, we can have real robot as a leader, or we can have virtual leader. Very interesting missions are defined for formation, more specifically for space missions, and NASA and ESA have defined very interesting missions in this area. Another application for formation control could be in dynamic coverage, that I would talk about it later. The other mission that I would like to introduce is coverage. I hope I can, okay. For coverage control, to clean the stains of oils or some dirt on the ocean. In this case, the environment itself is dynamic, so due to winds or waves, the shape of the stain is changed dynamically, and they should find proper position to be able to surround the stain and remove it as fast as possible. Another interesting thing that could be is that could be used in this team of robots is that we can have different type of robots with different capabilities as a team in order to enhance the performance. In that case, we can have heterogeneous robots. And this is very interesting approach for some missions, rescue, cleaning the ocean, firefighting, or slams. For example, you can see here for discovery, we can have a team of UGVs, aircraft or UAVs, even satellites, or in more general case, we can use the surface and the underwater vehicles as well. Or for firefighting, we can have a team of UAVs and UGVs that they monitor the fire continuously and fight with that. Or here we have a team of robots. It's a mission that is defined for a team of UAVs and UGVs to surveil the greenhouse more precisely. These are some examples, or the missions that are defined usually for swarming robots, or in more general case, as I said, the cooperative of team of robots. Thank you very much for your attention.